Hello, all. Welcome back to week two. If you're starting this on Monday, some of you might be running ahead of schedule and starting this over the weekend. But we're going to move on and we're going to start talking about consumer behavior and how consumers make decisions over what they're purchasing. Um, anyway, let's go ahead. It's not actually a very complex chapter. Should be pretty manageable. Okay, so first off, the learning objectives, feel free to take a screenshot of these. I'm not going to read them, but this is what we're covering in this chapter 3. Little applicable quote from Cicero. I think I pronounced it correctly. Cicero. Yeah, Cicero. And just the TLDR on this is that Rome was at its height of affluence just before 15, 20 years before Rome goes to Jerusalem and destroys the temple. So in history, that's how I remember that key point. I think it was 70, so it's 15 years. But the idea is, look, we need to focus on Rome and Roman people. You could argue Cicero is arguing to make Rome great again, right? The idea is that people needed to learn to work. People needed to, in the modern economic world, we call this embrace austerity, right? And austerity measures. And austerity is just kind of like taking a spoonful of medicine. Doesn't taste good, but it will make you healthier. At least it's the argument. There is some debate. Okay, so how do we measure what consumers want? So first off, let's think about it. We're going to be what we're developing is a theory of consumer behavior, a theory of demand, right? And the idea behind demand is that we all have things we want to buy, purchase, consume, right? So we can think about problem we're doing here is hamburgers and pizza, but you can really think about consuming cars, shirts, anything, right? And so economists start with some basic presumptions that your book really doesn't get into, but one is that people behave rationally, at least usually, right? And so what that means is even if you're making an irrational decision, you choose to use an illicit drug that could kill you because of lack of quality controls or whatnot, it doesn't entail one irrational decision doesn't make you completely irrational in the rest of your decisions, right? So the idea is even someone who's using drugs, which is irrational, they make rational decisions. And I always, don't want to make light in case someone had this experience, but if you're looking at meth addicts and you're reading the paper about, someone was out tweaking and they robbed someone, who's the meth addict going after? Are they going after, some big guy walking down the street? Are they going after armored cars? Or are they, more or less knocking over grandma, right? And stealing her purse. And I think that's what over time, I've noticed just anecdotally, a lot of headlines about tweakers doing really weird things and, getting in trouble with elderly people. Why? Because they're rational. They're going after easy targets. They're not going to go after the difficult targets just because they're doing one irrational thing. The other thing is we presume that consumers want more rather than less, right? This isn't actually probably true. Eventually people get sated. But for most of us, we have budget constraints, and those budget constraints dictate that we're going to have a limit to what we can purchase, right? But that doesn't necessarily always hold true, but we can treat it as being true for the most part in the aggregate, right? And so when consumers demand things, when they want to buy something, they would rather pay less, right? And they'd rather consume more. And so all of these things are going to be functions of how people make decisions. So one of the concepts that economics borrows from philosophy is this concept of utility. Utility has some stand-in words that are used in philosophy, right? So we can talk about the usefulness of a good or a service. We can talk about whether the good or service makes you happy. We can also talk about whether it does more good than harm, right? Or pleasure versus pain, right? There's this idea called the pleasure principle out of philosophy, utilitarian philosophy, that people pursue things that give them pleasure, not things that give them pain. And that idea of pleasure and pain could be relative to the actual consumer themselves, right? We all have different tastes. And so we're going to imagine that you fix your tastes in time, not that you can never change them, but to model things mathematically, we need to assume as few changes as possible, because math is really good at analyzing single variable changes. And the more variables that change simultaneously, the more removed we get from being able to have definitive answers. So we could take this idea of utility from philosophy and we mathematize it, right? And so what we're going to do is we're going to start with the utility function that's just an expression that allows us to rank consumption bundles or combinations of goods. And so if we have a two-good model of hamburgers and pizza, we just say total utility is equal to your utility from the quantity of hamburgers you consume plus your utility from the quantity of pizza you consume, right? So it's not necessarily going to be equal to the hamburgers and pizza unless the number of utility you get per hamburger is exactly the same or the pizza is the same, right? So if we wanted to modify this, way we'd have to modify this is the utility of hamburgers, and I don't know how to make it small, so we're just going to do this, times the quantity of hamburgers, and we'd also want to know the utility of pizza. And multiply that times the quantity of pizza, right? So it's a little harder than that. Well, let's go on. We'll go on and we'll look at this. Maybe I'll pull out a whiteboard after this and kind of write it down. Because what's really happening is your utility changes from each point, right? So we really want to index these values. I want you to think about how happy, think of your favorite food and think about how happy that food makes you, right? If you have none of it, we're going to assume that having none doesn't make you unhappy. That might or might not be true, right? You could imagine a world where there's some items, if you're not consuming them like air, you're very unhappy, right? So we're going to assume that, you know, let's say for sake of argument, mine is Werther's caramel chews, right? So I like something like that. So if I don't have any, I'm not unhappy or happy. I'm just at a zero utility level. If I have one, it might add 5 units of happiness. The second one might add a little bit more or less. What we know will happen, though, is that as you consume more and more of something, eventually the usefulness, the happiness that that good brings you goes down. Think about things that you have access to on a regular basis. It might not make you as happy as things that only come along every now and then that are special treats, right? So that's really what we're getting at there with this idea. And so we're just adding up the utility from every good consumed, right? The quantity of hamburgers. And we're just saying, okay, what was my utility for one? What was my utility for the second, for the third? And you're just adding them up. It's really a summation thing. And I'm not going to type that in basically because I don't know how to do summation symbols in PowerPoint because I've never had the need to. So it is what it is. But this is really what's happening, right? Is some modification of this. Sorry, I'm just reading. Something looks weird. But anyway, so you could take the total utility of the hamburger. It's not really going to work this way, but anyway. So we'll take this out. And we'll go back here. Okay. So the approach that the book is using assumes that utility is cardinally measured. Cardinal, you can think about, the book says that you use a ruler, and that's a pretty good example. So if you start with a number line and you have 1, 2, 3, 4, the reason we can say that 2 plus 2 equals 4 on that number line is that the distance from 0 to 1 is the same as the distance from 1 to 2, 2 to 3, and 3 to 4, right? The distance between each number is exactly the same, and that gives us this unit standard that we can use to measure things. In reality, utility is not cardinally measured. Mathematically, we'll make it cardinally measurable because it's easier to do the math. But we need to keep in the back of our mind, what we really are looking at is how people are rank ordering their preferences, right? So there we say, look, I prefer steak to asparagus, and I prefer ice cream to steak, right? And then we have this thing that says, look, we're going to have consistency amongst this. So that means that if I do that, then I prefer ice cream to asparagus, right? This is something called transitivity of preferences. And the idea there is distances don't have to be the same. Another problem of using cardinal utility is that my definition of 5 units of happiness might be different than your definition. So utility is very subjective to the consumer. So instead, we can talk about preferences, and we can talk about consumers making choices over consumption bundles of goods and services, right? That make them happy or less happy. So here we have three bundles. We've got a quantity of hamburgers that's giving us 2.5 units per one, I guess we'd say, or 2.5, and a quantity of pizza that's giving us 10. And based on the model, the algebraic model your book uses, which I'm not too happy with doing it that way, but we'll do it the book way. We're looking at 25 total utility, right? 2.5 times 10. And you can do that same math for all of the other problems. So just gonna look something up really quick. And so 3 times 7 is 21, 4 times 6.25 is 25. And to make a decision over what we want to do, we just need to look at the total utility. And we say, once again, people would rather be happier. And so what are the two choices that leave people happiest? It's choice A and C. Choice B is inferior because it makes you less happy, right? And so we would say that A and C have the same level of happiness. So at this point, with the knowledge we have, we can't say which one's better, right? To say which one's better, we'd have to know the price of those goods and how much happiness we were getting per unit of price, right? Is one way of thinking about it. So marginal utility is just the change in utility from one consumption of a good to another consumption of good. So the idea is that if we laid out, let me see if I can type this out. So if we laid out a little chart and we showed like the number of hamburgers, and then we do something like utility of the hamburger. And we'll take a step back and we're going to say this is really the marginal utility. Okay. Okay. And then we get over here and we're going to have total utility. Okay. So if we have this number of hamburgers being 0, then once again, we say we don't get any happiness. In fact, marginal almost means nothing in this sense. We can just give a dash right through it saying, look, there is no measurement here. Likewise, if we have 1 hamburger, we can talk about the marginal utility of that giving us 5 units of happiness. And the total utility now is 5. Our second hamburger I hate auto format, folks. Sorry about this. Okay. Then we get to our second hamburger. Anyway, sorry about this, folks. I hate how this is going. Okay. I'm just creating space for myself here, folks. So we've got 2. Imagine this is shifted over to the right. Sorry, just not going to be able to fix it right now. And our second one, the marginal utility, then is going to be 4. Then we get over total utility, it's just 5 plus 4, which is equal to 9, right? So the marginal utility is just the distance, the change from one utility level to the next, right? So if we go from 5 to 9, then we would say, look, 5 to 9 total utility, the distance between that is over that one spread is 4. Now, if instead of being 10, this number instead was, stupid Excel. Now we're looking at 10 hamburgers, give us marginal per hamburger utility of 5. And at 10, we're at 50. And so that's just the marginal utility over that spread. And then if we did 20 hamburgers, let's just assume that one's meaningless, folks, because it's not going to let me get rid of it. Anyway, we're at 20 hamburgers, and each one of those gives us an average of 4, then we're at 90 right here, right? For going 10 more units. So if we do that math, we do the marginal utility of hamburgers is equal to change in utility divided by change in number of hamburgers, then we didn't have this right here, we'd say 90 times the change from 50 to 90 is 40. So 40 divided by the distance here, which is 10, is equal to 4, which is our marginal utility per hamburger, right? So we don't have the data going 1, 2, 3, 4. We're going to need to do that division. If our data points are all 1 unit apart, all we really need to do is look at the change in total utility to tell us the marginal utility for that change. The other thing to mention is that marginal utility is really the midpoint between two consumption numbers of hamburgers. So technically, as we're going from 0 to 10, we're getting 5 units of utility per one, right? So it's not at 10, it's at somewhere between there, called the midpoint 5. Okay, and that just becomes our average. Anyway, so if we graph out total utility, marginal utility, what we find is that when total utility is at its peak is when marginal utility is getting to 0. Not certain why the textbook authors put it this way, but if you look, when marginal utility is at 0 on the bottom graph, then total utility is maximized at a consumption of, it looks to be about 10.5. Yeah, 10.5 hamburgers. So /11, right? Since we can't eat half a hamburger. So this is, hopefully you saw this in math at some point, talking about minimas and maximas. But the idea here is that utility over time is diminishing, right? So notice that downward slope of marginal utility. Notice that the slope of total utility flattens and eventually turns negative at some point. And that, once again, is the concept that the more you consume, the less happy something makes you, right? So I want you guys to think of eating those hamburgers. First hamburger makes you happy. For some people, the next hamburger could make them sick. Eventually, we all have that point where we just can't eat anymore, and we're just going to throw that hamburger up. That's where utility of consuming the hamburger is really going negative. In fact, for most of us, it's probably going negative before we're getting sick, but neither here nor there. Okay, so this is the law of diminishing marginal utility, that as we consume more of a good, the utility per item decreases, right? And this has some interesting ramifications, right, for goods that can be stored or not stored. So if you think about a food buffet, right, the reason food buffets can exist is because the owners of the food buffet know people don't have infinite stomachs, and you're not going to let them haul away goods. If you could store something, then maybe you need to lock it up. So let's say newspapers, right? Newspaper lock boxes, you used to open them, and you could grab as many newspapers as you wanted. But normally that wasn't a problem for newspaper companies. Why? Because the marginal utility, the happiness you gain from that second newspaper, is very, very close to 0 for most people. Now, if you're a mom or a dad and you're helping a kid with a paper mache project and you need a lot of newspaper, maybe you do go in and you grab 5, and then we're hoping on the honor system that people are ethical and don't do that, right? But newspaper boxes, it works to do an honor system where you put in 50 cents and you pull out 1 paper, because once again, the marginal utility of that second paper is so close to 0 for most individuals. If we were looking at putting in a candy vending machine, how many of you think that candy machine would be stocked very well if you just put in your money, opened it, and could grab your piece of candy? I know there's a lot of people that would be grabbing more than 1 piece of candy, right? Why? Because the marginal utility of additional units of candy is actually high enough to make people want to get it, right? So I've already talked about this, that we don't need cardinal measurement. We just need ordinal. We need to know what people prefer compared to something else. We don't actually need to do a lot of the fancy math on it that some economists like to do. Okay, so cardinal measurement of utility is both unreasonable and unnecessary. I've given you some of those reasons why it wouldn't work. We can use an ordinal measurement of utility, we need to know what's preferred to another. And the way we do that in modern economics is we use isoquants or isoutility curves. And iso just means equal. And so along this curve, you're indifferent or equally happy with all of the offerings, consumption bundles that you can choose. So if we have two different goods, tacos and hamburgers, and we're looking at the consumption, we can see that first off, we've got this downward sloping curve for both of these lines. The reason it's downward sloping is because remember, as you get more and more tacos, you get less and less happy from those tacos, right? And the other side is you're going to be trading off tacos for those hamburgers. And so as we're transitioning from tacos to hamburgers, so you can see when you're consuming a lot of tacos, you give up two of them, you're going to gain one hamburger, right? You're giving up two tacos, which represents some amount of utility, to gain some utility from hamburgers. And in this instance, you're going really from one hamburger to two. That might make you a lot happier, right? So you're indifferent between having one hamburger, 7 tacos, 5 tacos, 2 hamburgers, or at point R, even 4 tacos and 3 hamburgers. You're just as happy. When we move to this I7 line for 700 units of utility, what we can notice there is that all of these combinations, anywhere on this curve with N and P, represents more utility than any other point along the curve that's closer to the origin or closer to the boundaries, right, to the vertical and horizontal axes. So more, once again, is better, but maybe it's not feasible. Okay, so two indifference curves we've already talked about. One gives you 700 units of happiness, the other gives you 200. You would normally expect a number of additional isoutility or indifference curves, but we're just simplifying everything. We're putting one in at a time, right? We're just starting with 2 goods, and we're going to leave it with 2 goods. But we could do a fairly large number of curves. And one way to think about it is you could actually compare a lot of different items here as well, by even on a 2-axis curve, by saying, look, it's tacos or everything else you could eat, right? Instead of one other item. So normally we refer to the slope of the indifference curve as the marginal rate of substitution. Because these curves aren't linear, meaning they're not straight, they're curved, they aren't going to have the same marginal rate of substitution on curves. So we're going to do point estimates. And you might think of this from a math class as the point slope formula, right? To find the slope of a curve between 2 points. And so we're always going to be looking for the marginal rate of substitution between 2 different points. And so that marginal rate of substitution is equal to the change in the number of tacos divided by the change in hamburgers. And that tells us what's happening. So the marginal rate of substitution reflects the number of tacos you'd give up to get one more hamburger, right? Pretty much you're bartering with yourself. So if we want to do this and we're looking at implementing that formula, then we have the number of tacos given up, which is -2, divided by the number of hamburgers gained, which is 1. And so that means your marginal rate of substitution between these points is -2. Likewise, we could go from Q to R, and we could say, look, going Q to R, you're giving up, 1, and you're gaining 1. So it's -1 divided by 1, which is -1. So your marginal rate of substitution from point Q to point R is just going to be equal to -1. And we can do this for any 2 points on the curve. Once again, if we have the special case of a straight curve, that marginal rate of substitution is fixed amongst all points. We only need to calculate it for one area to figure out the marginal rate of substitution for the whole line, right? Okay, so what this means from consumers' perspective is that essentially 2 units of tacos are equal in happiness to 1 hamburger between those points, right? Assuming you were already consuming 7 tacos. It's a lot of tacos anyway. So along the same indifference point, the decrease in taco consumption from point M to point Q times the accompanying increase in the marginal utility of tacos must be identical to the increase in consumption of the hamburgers from point M to point Q. All we're doing here is setting up a ratio, right? So the change in tacos times the marginal utility of tacos is equal to change in hamburgers times the marginal utility of hamburgers. And if we rearrange that equation, we get this ratio, right? And this ratio is pretty easy to set up. So it's change of tacos over change of hamburgers is equal to marginal utility of hamburgers divided by marginal utility of those tacos. Both of those ratios are going to equal the slope of the indifference curve. Let's fix that typo. Very good. So if we move from there, we want to figure out what choice you're actually going to make. We need to develop a concept called the budget constraint, right? So you have these ISO quants that are giving you your utility bundles that you're indifferent between. And I said before, budget's going to have a play in here. So what that means is the price of hamburgers times the quantity of hamburgers plus the price of tacos times the quantity of tacos you consume has to be less than or equal to the amount of money you have to spend, right? So you're going to choose to consume these items relative to their price at a point that makes you happiest. So 3 requirements for the budget line, or 3 assumptions, right? The amount to be expended. So you're going to need to have the expenditure income. You're going to have the price of good 1 and the price of good 2. Okay. So in this sense, we're doing the price now, and we're using the quantity of tacos and hamburgers as the amount you plan to consume during 1 week. Normally, when I would do this in an in-class lecture, I'd say we would just do it for what you consume during class, right? A lot of times I like to set up a little station and have 2 or 3 students volunteer and come up, and we just feed them junk food, right? It's a fun activity. And so the idea is, you know, you're going to get this. How happy did this first one make you? How happy did the second, right? So, and then we can do that in terms of saying, well, the candy costs this much per unit. How much do you have to spend? And you're going to keep consuming different bundles of junk food until you're out of money or at peak happiness, and you're going to be unhappy from consuming more, right? Either condition. So the budget constraint limits the amount that can be spent on items. A graph depicting this constraint is the budget line, and the slope of the budget line is equal to the negative of the price of hamburgers divided by the price of tacos, right? Sometimes easier, in my opinion, I'm going to be blunt, to just graph the thing out, choose 2 points, and do the calculation, right? You could actually have done the same thing with quantities, right? You just have to inverse it, but it is what it is. So if tacos are 50 cents each and you consume 10 tacos, then 10 times 50 cents is $5. If you have hamburgers at $1.25, if you consume 5 tacos and 2 hamburgers, you spend $5, on and on. All of these represent constant combinations on a budget line. So when we look at the budget line for taco consumption, we're saying our budget's $5. And so every point on this curve equals $5, right? So anything between A and B and C is going to be $5 spent. So if we change taco prices, we can increase or decrease the number of tacos we can consume for the same person if their budget doesn't change. So if the price of tacos goes up to $1, then you can only afford 5 hot dogs. You can still get 4 hamburgers because remember, the price of hamburgers didn't change. They're still $1.25. If we cut the price of tacos to 25 cents, you can now get 20 tacos, right? Same thing with hamburger. We can change the price of hamburger and it's going to shift the line in and out across this, but still anchored to the axis for 10 tacos at 50 cents a piece. So what happens instead of just changing the prices? What if we change our income? If you have $5 here, then that means, or sorry, $5 here, it means you have $2.50 to spend here. And if you go out here, it means you now have $20 or sorry, $10 to spend out here, right? So changing your income shifts the whole curve. Changing the price just shifts along the axis for the price of the item that you bought. Okay, The budget line would shift out to line AE. If the price and A to E is this black line going from 4 to 20, the E's kind of cut off there. Sorry about that, but is what it is. So let's go back one. Okay. So if the price, so what's happening there is we've got the price of tacos falls in half, right? And so we're going out to this A to E. So finally, the budget line would shift out to line BB, the other black line, if the price of hamburgers fell in half, or in line to the price, in line BG if the price of hamburgers doubled, right? So B to G is in, B to D is the outside. So this leads us to one of the laws of economics. There's not a lot of laws we're going to talk about. One is Engel's law and our Say's law, which is supply creates its own, supply creates its own demand. Pretty antiquated, but works for agricultural communities pretty well. Might not work for technological goods or other types of goods. And then we'll talk about the law of demand and law of supply, right? Law of demand being as you purchase more, as price goes up, quantity demanded goes down, and as price goes down, the quantity demanded of good goes up, right? So as things get more expensive, you want less of them, right? Pretty intuitive. And then we'll talk about law of supply. And that's when the price of something goes down, producers want to supply less of it. And when the price goes up, producers want to supply more of a good, right? So if you're bringing cotton to market and the price is high, you really hope that your cotton crop is good, right? Because you want to sell as much as you can produce. So Engel's law, though, is the idea that the more wealthy a consumer becomes, the less you spend on food, right? And so if we think about it this way, and this is graph of personal disposable income spent on food from 1990 to 2014. And we don't have the graph there, but we know from 1990 to 2014, incomes have gone up, right? Even adjusting for inflation, they've gone up a little bit. And so the idea is as people become wealthier, they just spend less. I want you to think about that. There is a point, I will say, I grew up in pretty poor circumstances and I've had some bouts in poverty in my lifetime. And I can say, look, as you become wealthier, you might spend more on food because you're so used to eating shitty food that the idea of having a good steak sounds nice, right? But in general, as you become wealthier, you're going to eat the same things. You're not going to do different things at a certain point, right? Maybe it gets a little more expensive when you eat out, but at home, you're still eating what you eat. Little interesting examples of that. Think about Trump and his love of McDonald's, and Warren Buffett, one of the wealthiest men in the world, and his love of Coke/Diet Coke and Cheetos, I believe, is his other snack junk food that this man likes, right? So I imagine with the Cheetos, McDonald's type diet, Coke diet, you're not going to be spending too much on food over a long run, even though you have money and could buy anything you wanted. So this is just another way of looking at it. It's the share of total food, money spent on total food as a percentage, and this disposable personal income. And as we see, as income goes up, the amount you spend on food goes down. So where we're going next is to talk about the consumer equilibrium. We're going to start putting this together, and then we're going to mesh in supply at some point as well, and talk about how people produce or supply goods to the market and how that interacts with the demand of goods. But for now, that's all we have. So thank you for attending and have a good day.